Assalamualaikum and good day. How are you today? So let's continue our lesson on chapter 3.3, integration of power of sines and cosines. So
Cosines, okay. Now, even though previously we have dealt with the trigonometric functions, but here in this subchapter we are dealing or focusing more on how to integrate the complicated trigonometric functions. Okay, it comes in the form of like this, right? Integrate sine power of m x cos power of n x dx. Okay, so here we are dealing with power of 2, 3, 4 and etc. Okay, so how you want to solve this? Actually, there are three cases that we need to deal with or understand. Okay, the first case is when the m here is odd and the n is even. Okay, that is the first case. Okay, next is the second case here. Alright, is when the m is even and n is odd, and third case is when both of the m and n is even. Okay, so we have odd and even problems here. So let's deal one by one. So for the first case here, when the m is odd and n is even, it means that when the m is 1 or 3, right, or 5. Okay, 1 is simple. Okay, when the power is 3, 5, 7, the odd numbers. Okay, what happened is that, okay, this is an example of when the m is odd. Okay, so we have sine power of 3x dx. So how you're going to solve this? Okay, you need to remember that there is one identity that you need to apply, which is this one. Sine squared x equals to 1 minus cos squared x. Okay, so you need to use this identity. So the example related to case 1, you can refer to example 3.27. We're going to discuss this one further after this. Here we have example 3.27. You need to evaluate sine cube or sine power of 3x dx. So if you look at the power here, okay, so here m is odd since the power is 3. Okay, so it falls under case 1. You know that you need to use this identity. So this identity is actually comes from here. I believe that you can recall it. Sine squared x plus cos squared x equals to 1. Okay, so since we want this only, that's why we need to move the cos squared x to here, so that it becomes 1 minus cos squared x. Okay, so what is the first step that you need to do? So this is the first step. You need to break it down, sine power of 3 to become sine squared x sine x. Okay, so that we can substitute the trigonometric identity into this. Okay, that's the main idea. Now, once you have plugged in, okay, sine squared x with 1 minus cos squared x into this, okay, so the integral will become like this. Okay, the integral will become like this. 1 minus cos squared x times sine x dx. So from here, you can apply the substitution of u, okay, by choosing u or by choosing cos x as u. Then you differentiate it. So you need to remember or memorize the u substitution, yeah, or integration by substitution. Okay, so this is the second step. Okay, let me write down it for you. The second step, we can apply the integration by substitution. Here we can pick cos x as u, and then we differentiate it. It will become minus sine x dx. Alright, so we just plug in here. Okay, since sine x dx equals to du, so here is our du. Okay, and then 1 minus u squared. Okay, since our u is cos x and we have the power of 2 here, and we bring the negative down, we write it here. So the next step is that you just integrate it. So integrate 1, you'll, with respect to u du, you'll get u, and then u squared, it will become, when you integrate it, it will become u power of 3 over 3. So minus, okay, positive here, plus c. So your final answer should be right in the form of variable x. So we replace u with x, and your final answer, your full final answer will be negative cos x plus 1 over 3 cos cube x plus c. Okay. So let's move to another example, which is when there is a combination of sine and cos function with m is odd and n is even power. So let's have a look on example 3.31 for this case. Right, so here we are. You need to evaluate sine cube x cos squared x dx. So this is a combination of m odd and n is even. Am I right? Odd power and even power. So the first solution or first step, okay, is you need to break it down the odd power. So from the, you don't for the time being, okay, you don't do anything to the even power, which is cos squared x. We only break down the power for the sine power of 3, so it becomes sine squared x sine x. Okay, so once you have chunked it into sine squared x sine x, you need to substitute with the trigonometry, okay, trigonometry identity. Okay, since this is odd power, so we use sine squared x equals to 1 minus cos squared x. Okay, only then, okay, so what happened is that here sine x, we put it over here, and this is the cos squared x. Alright, so from here we can do the integration process. Okay, so by using u substitution equals to cos x and du equals to negative sine x dx. So everything you plug in here, and then this is very easy, very straightforward. Okay, your final answer must be in x variable. So I don't want to explain this one because this is very easy. by now you should be able to do the integration process. Okay, regarding case 2, okay, when the m is even and n is odd. Alright, so this is the example when the n is odd. So n is basically referring to the power of cosine function. So here we have cos power of 5x dx. So you need to use this identity. Okay, cos squared x equals to 1 minus sine squared x. Okay, next example is example 3.28. You need to evaluate cos power of 5x dx. Alright, so what can you deduce from this example is that, okay, here we have power of 5. So power of 5, okay, this is n equals to 5. It is odd number, 5 is odd number, and we have cos function. So it means that we are dealing with case 2. Alright, case 2 is when n is odd. Alright, so you know that you need to use this identity, okay, as I have shown in the mind map just now. So cos squared x equals to 1 minus sine squared x. Again, the solution is that you need to break it into this form, cos 5x. Alright, so we chunk it into cos squared x. Okay, right, so if you have power of 2 here times cos x, it is actually this one, cos 2x. You can plus it here, plus 2 cos x. So this is cos 4 power of 4x cos x. So this one you can, this one is actually 1, okay, 1. So you can add up it like this, yeah. So it will become cos 5x. Okay, you'll get the original question here. Right, now move to this. Okay, so this is actually your first step, okay, or step 1. So step 2 is, okay, you need to plug in. Alright, here the cos squared x, okay, you substitute 1 minus sine squared x into this, so it becomes here like this, times cos x dx. Your step 3, okay, will be pick the right substitution. Okay, here sine x is u, so du will become cos x dx. And when you plug in here, alright, so anything related to sine, okay, anything related to sine will become u. And here cos x dx is du, so that is why we write down here. So 1 minus u squared, okay, power of 2 du. Start from here, you can just integral it using the power rule method. Okay, so integrate 1 becomes u, integrate 2u squared, it becomes 2 over 3 u cubed plus 1 over 5 u power of 5. This is for u power of 4 plus c. and your final answer should be written in the form of variable x. Okay, this is another things that I want to share with you. It is what will happen if there will be a combination when m is odd and n is even. So how to solve this? We're going to look into this example later on. And then another condition is what happened when the m is even and n is odd. So just now, okay, when m is odd and n is even, okay, m is odd and n is even. Now what happened if the combination when m is even and n is odd? So this is the example that we're going to discuss. Identity. Now regarding the third case here, it is when both are even. Okay, so when both are even, so I split into two examples here, when the m is even or when the n is even. Okay, so m related to sine function, so sine squared x equals to half 1 minus cos 2x. This is the identity that you need to apply when the m is even. Whereas when the n is even, n is related to cos function, so you need to use this identity, which is cos squared x equals to half times 1 plus cos 2x. You don't need. So let's move to example 3.29 and 3.30. So here I combine these two examples because both of these examples are actually under case 3, where the m and n is even. Okay, so we have here, for example, power of 2, and here we have power of 4. So since this is involve the even power, okay, so we will use another trigonometry identity. Okay, here we have sine squared x equals to half times 1 over cos 2x. Okay, you just substitute this one into the original function here, so it will become half. So there, because this is the constant, you can take it out from the integral. We put it here, half integrate 1 minus cos 2x dx. So when you integrate 1, it will become x, and when you integrate cos 2x, it will become half sine 2x plus c. So you can leave your answer like this, or if you want to make it, if you don't like the fraction inside the bracket here, you can just take it out. Alright, so it will become 1 over 4. Okay, and here if you cancel 2 with 4, okay, you'll get x back. Alright, so either way, both are acceptable. Now move to example 3.30. Evaluate cos power of 4x dx. Here we use different trigonometry identity, which is this. Okay, cos squared x equals to half 1 plus cos 2x. So just substitute here into this. Okay, it becomes like this, right? Okay, this is quite tricky. You need to expand this one. So when you expand this, okay, you have 1 plus cos 2x squared, right? So you need to expand it, 1 plus cos 2x times 1 plus cos 2x. You expand it, okay, using the algebra techniques, okay. It will become 1 cos 2x, okay, here cos 2x plus cos 2x, you'll get plus 2 cos 2x and plus the last part here, cos 2x times cos 2x is cos squared 2x. So if you notice, you encounter again cos squared 2x, it means that you need to apply this one again here. That's why you notice that, okay, you have to plug in 1 plus cos 4x. Okay, why cos 4x? Okay, here's the trick that you need to master it. So you know that cos squared x is half 1 plus cos 2x. Am I right? So now we have cos squared 2x. You have the constant 2 here. So what you need to do is that here you need to, okay, this is no longer 2, okay, it's no longer 2, but instead you need to times up with 2 here, so it will become cos 4x, okay. Hence the reason why it becomes like this, okay, half plus half times 1 plus cos 4x. Okay, this is how you get it, yeah. Okay, this is you need to be very careful, okay, how you want to solve this. Okay, it ends up to be like this: 3/2 plus 2 cos 2x plus half cos 4x. How come there is 3/2? So 3/2 is actually coming from, okay, 1. Okay, we have 1 here, okay, 1, and then we have half here. Okay, you need to expand this one, okay. So 1 plus half, you will get 3/2. Okay, so don't forget that you need to expand this one as well. Okay, and to expand it. Next, when you already get in this form, only then you can proceed your integral process. Okay, so I will not explain further on how you should integrate this one. You should be able to do it by now. So again, this is your first step. Okay, then consider this as your second step. Okay, and finally your third step is the integration. So this is example 3.32. In this example, we are looking into what happens if the question is a combination when the m and n is even, both are even. Okay, so let's check it out here. So here, example 3.32, we know that both m and n is even, is 2 and n is 4, yeah. So you know the first step is, okay, we need to identify the trigonometry that we're going to use. So okay, this is the trigonometry identity, please remember it. So if you check it out here, okay, what happen if you want to use the even powers? So we use here half 1 minus cos 2x, and half 1 plus cos 2x. Okay, right, so here we have, okay, if I can write it down for you to make it much clearer. So we have sine squared x times cos power of 4x. Alright, okay, no need the x. I just want to show you how to break it down or chunk it. So we know that sine squared x, since this is even case, okay, we use half. Okay, let me check, double confirm the trigonometry identity. So it is half 1 minus cos 2x, 1 minus cos 2x. Right, so this one you can just straight away plug in here. And we also have cos power of 4x, so this is cos squared x. Alright, cos squared x power of 2. Right, and this is, since this is even case, so we use this trigonometry identity, 1 plus cos 2x. Okay, and the whole this is squared 2, so you'll get 1 over 4, 1 plus cos 2x squared. Okay, now if we combine this and together with this into the original equation there, you should get half 1 minus cos 2x times 1 over 4, 1 plus cos 2x power of 2. You will get 1 over 8. Okay, this one can times up together, and then 1 over cos 2x times 1 plus cos 2x squared. Okay, since this is in the form of factor, so you can expand it. Yeah, so when you expand it, it will become, okay, 1 over 8, 1 minus cos 2x, so it will become 1 plus 2 cos 2x plus cos squared 2x. So basically this is what this is similar to here. So in your module, okay, it has been summarized. Okay, it skips all this, but in reality you need to calculate like this to get into this. Okay, I hope that's clear. So next is, okay, you need to expand this one. Okay, each of these term, alright, here, here, and here. So once you expand it, try to do it at home. Make sure you can get the same exactly like this form. Okay, now if you notice that we have power of 2 and power of 3 here, so this one you can settle it down straight away. You can integrate it straight away. 1 will become x, and cos 2x will become half sine 2x. Now for the remaining here, okay, they are in the form of power, if you notice. So if cos squared 2x, we use, this is even case, so we use this trigonometry identity to solve it. And as for odd power here, we use the case 2. We have discussed previously, so I don't want to explain it here anymore. You can refer to the previous minutes of the video. and this is the solution of cos power of 3. And then what you need to do is that you need to combine your answer starting from here, okay, and here to become the final answer. Right, so basically this example is quite tough, and I recommend you to do again starting from here. Okay, follow the procedure that has been explained here. Okay, otherwise you will not learn it by yourself. Right, so try to do this example at home, and also together with example 3.33. You can refer it in your module. Alright guys, so stay tuned for my next video.